I was discussing regarding approximations. So, this is basically known as the linear approximation. In this case 1 minus x raised to power minus 1. This by your expression is basically 1 plus x square plus x cube plus so on. But I am using this equivalent to 1 minus x raised to power minus 1. This is equivalent to 1 plus x. In this case, I am taking only the linear part, meaning there is that the term of x square, x cube and so, because for small values of this x, these terms can be neglected. So, this is the linear approximation, and similarly if I take the term up to x square, so that is the quadratic approximation, and once again everywhere I am using the fact that mod x is less than 1. Now, let us see a sort of application of these approximations. So, I find out the approximate value of square root 3. Well, with the help of calculator you can do it, you know the value of square root 2, that is a standard value. But as an application of this expression, let us see what we get. So, we consider for example 4 minus x raised to power half, and obviously I want to get the value of 3 raised to power half. So, ultimately I will choose x is equal to 1. Let us see what we get in this case. So, 4 minus x raised to power half, as usual I will make the first term as 1. So, I take 1 as common, 4 as common, and what left inside the bracket is 1 minus x upon 4 raised to power half. 4 raised to power half, all of you know, that is 2 into 1 minus x upon 4 raised to power half. I am using the binomial expansion. In this case n is my half. So, I will get is equal to 2 into 1 plus n into x, that is half into x is minus x by 4 plus half into half minus 1 upon factorial 2 minus x upon 4 whole square and so on. And if I simplify it, this will be 1 minus x upon 8. This is plus of minus, this is not plus. Then plus 1 upon 128, and if I take the value of x as 1, so the left hand side becomes 4 minus 1 raised to power half, and the putting the value of x in the expression 2 into 1 minus x by 8 plus x square by 128. This I am approximating it by 113 upon 64, and that was the approximation for square root 3. And in this case, this is an example, you can try yourself. Expand this 1 plus x raised to power half up to the term in x square and put the value x equal to 2 by 9 to obtain a a, rational approximation for square root 11. So, after doing this, putting the value, we will get square root 11 is equal to 179 upon 54, and if you find out the value, because you just observe it, that is 3.315 up to 3 decimal places, and therefore square root 11, that will be 3.317, that is the value which you computed with the help of calculator. Now you look these two expressions, or rather two values, one is 3.315, other is 3.317. So, either you use this binomial expansion or you take the help of your calculator. Up to 2 places of decimals, the value are precisely same. And here is a simple use of partial fractions, because if you want to find out an expression of this type with the help of binomial theorem, then first of all you write down each term or this expression as the sum of linear terms, and for each linear term the expansion is available. So, this is the trivial way, for example 5x minus 1 upon x plus 1 into x minus 2, you put it as a upon x plus 1 plus b upon x minus 2. So, choosing means x is equal to minus 1 and x is equal to 2, you can get the value of a and b. So, ultimately you can write this expression equivalently 2 upon x plus 1 plus 3 upon x minus 2, and that is 2 times 1 plus x raised to power minus 1 plus 3 times x minus 2 raised to power minus 1, and of course both the expansions are standard. So, you can expand this as well as the first term, that is 2 upon x plus 1, and the second term, that is 3 upon x minus 2. So, ultimately you will get final answer as 2 upon x plus 1 plus 3 upon x minus 2 is equal to, this was the expression for the first term, that is essentially same, 1 minus x plus x square minus x cube, and that is for x minus 2. So, minus 3 by 2 and so on, and this is equal to half minus 11 by 4 plus minus 13 and so on, and this is the validity of this expansion, means you can see with the help of these yellow lines that the expansion is valid for mod x is less than 1 and mod x is less than 2. So, both the inequality will hold when you are having certainly mod of x is less than 1. Then these are the problems for you, trivial problems, but just for the sake of exercise, this is problem B, again problems, and problem E, and finally thank you very much.